This is the talk, Monads for Java developers. Now, after the survey, the quick survey they did, I know that some of you have an idea of what is a monad. So, yeah, let's see how it goes. I'll try to be as clear as possible. So this talk is based in 2 blog posts that I wrote in June. I was meant to present this at my company, so I said, instead of writing the presentation, I'd rather write the blog posts. It seems it went pretty well, so I said, well, why not? Let's try to share it here. It's sort of introductory talk targeted to object-oriented developers that has Java experience. The requisites that you need are, cool. Basically, you need to have worked with Java 8. You need to be familiar with the Lambda syntax in Java 8. And also, you need to have some experience with generics. If you have that requirements, you will be good. I don't know if you will get what is a monad, but at least you can say that you attended the talk. No, I think it's easy. It's easy. I think we can cover it. On the other hand, if you have functional programming experience, this might look a little bit basic, but nevertheless, it's good to know how we transform those concepts into the Java language. Cool. So let's get started. Let me do something, sorry. Just trying to reset the timer, and then let's go. All right, who am I? My name is Andrés Castaño. I'm from Colombia. I've been working in Java for a while. Different type of projects. Also, I've done some things in the front end with JavaScript. I'm a functional programming enthusiast because I'm still learning. It's cool. I like it a lot. But this talk is not trying to sell you functional programming concepts or functional programming things. I would try not to touch anything about, this discussion between, object-oriented versus functional. I'm still not sure that functional programming is the right way to go, but there are cool things in there that we can bring to Java. So yeah. And I'm currently working at papercut. Papercut is a homegrown company, software company with 18 years in the market. We have Melbourne development teams, but we have gone global. We have offices in Portland, and yeah, maybe some more offices will come soon. We have a lot of clients, around 50,000 clients. Some of them, we have NASA, Starbucks, Cambridge, Harvard, and we do print management. So we got a cool company that the domain is not that cool, but it's nice. We are helping companies to reduce the printing waste and to monitor printing. And yeah, we've been pretty successful with that. Yeah, that's my Twitter. I'm rather active. You will find I will share the presentation, of course. You will have the links to the articles at the end. But then if you say, like, this guy talked too much crap, let's follow it, then you can follow me. Alrighty, so this is what I'm trying to cover today. At the beginning, it's not going to be the 3 points there are not like hard boundaries between each one of them. It will be more like a constant flow of things. But I will try to cover a little bit of introduction about monads. What are monads? I will try to cover some of the built-in monads in Java 8, because Java 8 already have monads built in the JDK. And then we will try to build a couple of custom monads, depending on time. Let's see how it goes. Let me see if I have something more interesting here to say. Cool, is this, what? Stop, okay, cool. So, why should I care about monads in Java? All right, I'm a Java developer. I've been working in Java for a long time. I'm happy. I have everything covered. I've done awesome systems. So why in heaven I should take care about monads? And I have some reasons. Let's see. So monads in Java, you can think of them as a design pattern. It's a different way to do things. And the pattern will help you manipulate certain types easier. And the types I'm talking about are basically generic types or parameterized types. So it's just a new way of, it's another way, not a new, it's rather old, but it's another way of doing things. Strictly speaking, it's more than a pattern. It has a huge mathematical background that I won't touch. It has a lot of functional programming implications that I won't touch. But in Java, I think it's fairly safe to approach to this as a design pattern. They have other benefits, not only for parameterized type, not only for interacting with these generic types, they have other benefits like, side effects free and referential transparency and all of these things that functional programming promises, but I'm not talking about that neither. So, because if it is a pattern, using monads, of course, is not mandatory at all in Java. They are just another tool that you can use, or you can decide this is crap, I won't use it. In other languages, monads are mandatory. You cannot write certain type of languages without using monads. In Java, it's an optional feature. What else came there? And the other thing is that it is optional, I say, because it lives in the boundaries of the Java type systems. There are things that you cannot do with monads because the type system in Java is not strong enough. And I will try to explain that later. But it shows a different way of using the language. It's not super different. You might be already familiar with it, but it's not that common. And also, because Java 8 included some functional capabilities and some syntax sugar, it makes it easier to write monads. Technically speaking, you could use monads. You could have used monads since Java 5, since generic were introduced. But it was a little bit more cumbersome. In fact, since before Java 5, without generics, you can argue that you can have used monads as well. Monads, yeah, the good thing is that monads play very nicely with type systems. So yeah, this is a good thing to have in Java. So, look, it's not mandatory, it's not super important, but it's another thing that you can have in Java, and we are all Java developers, so why not? So why not taking a look at it? There is another that it's my personal, the reason why I choose to learn and try to use monads in Java is that monads is a concept that is super critical in other languages. In Haskell, for example, I'm trying to learn Haskell. It's very nice. In Haskell, for example, monads are critical. You cannot write any Haskell program without monads. You need at least one monad, which is the IO monads, something different. But for me, it was like, okay, right? I've been working in software for 10 years or so, and there are concepts that are super critical, super important, that like the ground things that you need to learn, to know, to be able to use a language, and I don't even know what it means. So some say, like, all right, let's give it a shot and see how it goes. And it turns out that at the beginning it was a little bit, what is this? And then just made click. See, don't understand. Let me see. So what are monads? Right, this is the core thing. In Java, monads are parameterized types. Parameterized types are generic types. We will go a little bit deeper in that. I want to set the ground or the common terminology that we're going to use to the rest of the talk. So it's a type that implements two methods. One method is called bind, another method is called unit. Most of the built-in functions, most of the built-in monads in Java, the bind method is called flatmap. All right, so bind and flatmap are the same thing. And unit. Unit has different names. We will see in the talk. And a monad has to follow these three rules. left identity, right identity, and associativity. I won't talk about them. The thing with monads is that, look, the reasons are, first, it will make the talk a little bit longer. Second, in my opinion, the benefits that these rules brings to monads are not super critical in Java because the Java type system is not a functional type system. It's a little bit, it's good, not good enough. So believe me, there is no need to learn about these rules right now. If you want to go deeper inside monads and functional programming in Java, then you might want to learn them. But for the time being, I will try to leave them outside. I'm happy to discuss with you after, or maybe have a coffee after that and talk about monads and laws and category theory and other things. But for the time being, no need. All right, so terminology. So this is one thing that I want everyone to be aligned in the same field, in the same plane. All right. So parameterized type is a generic type. It's called optional, for example, optional string, right? This is a type that has a parameter. The string is the type parameter, right? It's normal Java jargon. And the optional is the wrapper type, or the generic type, or the parameterized type, right? So the optional itself doesn't make sense. You cannot have just optional. It doesn't make sense. In Java, turns out that if you write optional, by default, the parameter is what? Object, right? Because it's just sort of syntax sugar. But as a concept, an optional is not valid by itself. Optional of what? Like a list. If you have a list with nothing, it's just... Nothing. Yeah, exactly. So you need, for the type to be concrete, to exist, it has to have a type parameter. In Java, again, it happens that by default, the type parameter is object. But it has to have a list of something, or you have to have an optional of something. In this case, you have an optional of a string. So we can say that a string type is wrapped by an optional context. So the optional wrap gives context to the type parameter. In this particular case, what is the context? The context or the functionality that the optional thing adds to the string is that the string might be there or might not. All right? So the string type is wrapped in an optional context. The string is the type parameter. The optional is the wrapper type or parameterized type or generic type. All righty? So this is just Java 8. Nothing new here. So again, a monad is a parameterized type that implements bind and unit and follow the three rules. The three rules, we are not going to touch them. Parameterized type, we already talked about them. And then now let's go into the methods. If I'm going too fast, just let me know. And yeah, I guess we can have questions anytime.
So would you say an optional then is something that it's like a wrapper around something that could be null?
This is not a value. This is a type. So it's a string. It's something, yeah, it's something that can be done. Yes, definitely. Yes. From the optional itself, I guess if you create optional of null, I'm not sure, but I guess you will get an exception there. You need to get optional from nullable so that you can create an optional itself. So if you pass null into an optional when creating the optional, I think it's not allowed.
So what I just meant was a class that is an optional string. The string it contains might be null, or it might be there, or it might not be there.
Exactly. So it's not the string that it contains. Sorry about this. Come on. Cool. So it's not the string that it contains, it's the whole optional thing. The whole optional thing might be empty or might contain a value. The whole optional, the whole parameterized type. The string itself is a string, right? The string by default can be null or not null, it's just a Java property. But the whole composition of thing, the whole monad, all right, I give it away. Optional is a monad. So the whole optional, it can be there or it cannot be there. All right? Oh, sorry. Sorry. I won't move. I won't move that much.
Alright, that's good. That's right. It's like the cricket, you have the speakers. Sorry, you can speak. Yeah.
All right, so let's go into the methods. All right, so.
Give me some music.
No, that's good. Because it was getting too bored. It was getting too bored and people were sleeping. So well done.
That was good.
If you keep seeing people going to sleep, just turn the music on and that's it. So, as you can clearly see in here, a unit is a method that will take any object and will create a monad out of it. In the case of optional, it will take any type and will produce a monad. So the unit method in the optional monad is called off. Basically, you create an optional from any type. All right? So that is a simple method. Any type you pass, you will create an optional. If you pass null, I think you will get an exception there. Of nullable. You can do optional of nullable, and then you will get an optional. But if you pass optional, and then instead of example you pass null, I guess you get an exception there. Yeah, I think so. Cool. All right, so this is the unit. All right? And now we have the bind method. The bind method in the optional monad is called flat map. I guess in Java, most of the built-in monads contains the flat map method. And that method is very particular and a little bit tricky, but it's very cool. So let's forget about, I will try to use the pointer here. Let's forget about this bit. So if you've worked with Java 8, you know what is this? This is a function, right? It's lambda. So it's a lambda that receives something and returns something in here. Okay? First, to try to understand this, let's not worry about this. So the flat map is a method in an object that receives a function. We'll see what is that function later. And what is the return type? Another optional, right? So you have an optional one called example because you created an optional from the example string. And then you can apply the flat map there. And the flat map there will have a function as a parameter, and it will return another example, another monad, right? So that part is cool. Now, what is the function? The function will receive a value, which is the type parameter value at that particular time. What is the type parameter here? String. It's a type. It's a string. What is the value of that type parameter? Example, right? So this value here will be example in this particular time. And the return, so the signature of that function is you receive the type parameter and return another monad, another optional. All right? So this is the most tricky part. If we get this, we go through the rest of the talk super easy. So we have an optional that have a method called flatmap that receives a function. That function, in turn, receives the type parameter value and returns another optional. All right? That function is called mapper. Keep that in mind. That is the mapper function. The result of this would be another optional that, as you can clearly see here, it says modified example. You cannot see a thing, but yeah. It says modified example. All right? Because that is what I did in there in the function itself. I will bring a lot of more other examples of flat maps. So if you are not 100% with this, we will continue and you will get it.
I don't think that people can see the modified example wording there.
Sorry?
I don't think that people can see. This word modified example.
Yeah, I was being ironic. I know nobody can see this. This is sorry, it was my mistake. I'll try to. Yeah, I cannot modify it. But yeah.
Sorry.
Go ahead.
Do I have to return
optional of integer.
Optional of anything, as long as it is an optional.
Okay, fair enough. Thanks.
Cool. Yes, you're right. I will try. I will try to. Yeah, I guess with the next examples, people will have clearer. Yeah, it was. Yeah, it's my fault. The presentation was crap. Yeah, please go ahead.
Why is it called flat map?
All right. So, flat map is because we have actually something that maps one thing to another and flattens out the response. Example. I guess we know what the map function does in a list, right? We have a list and you do a map and then you produce one element and transform it into another element and then the result will be another list of all of the elements. In optional, you have the map function as well. So you have a map, a function that says optional string, that receive a value and then you return another value. What happens is that if you return another optional inside the map function, what you get as a response? You get an optional of an optional because the return value of the optional is another optional, right? So it has optional of a value, right? The flat map, different than map, it takes these nested optionals and flattens them out as a single thing. Maybe I can show some code, I guess. Let's see if I can. How do I do this? Let's see. All right. Arrangement, mirror displays. Cool. You can see this thing now. Let's create a method here, whatever method. So we have optional string a equals to optional.of whatever, right? So if you do a.map and you pass a value, you can do so the return type of this is an optional string. All good with that, right? But if for some reason the mapping function can't return another optional because the mapping could be something that might fail, and so I want to return another optional, then I can do, if I do the result, because for some reason this thing could be empty, right? Then the return type is an optional of an optional. See what I mean? So the flat map, what it does is flattens the response out into a single thing. And now you have an optional in there. So even though I return an optional inside, it takes and aggregates the optional together. Go ahead, man.
Usually it's better to use flat map than map. Or
It also
it's better to use map.
It depends. It depends of your use case. If in the map, for example, for optional, this is a little bit off the topic, but yeah, from the optional point of view, if the operation that you run inside the map might fail or might return an empty thing, then yeah, makes sense to use the flat map. If the operation inside is for sure that it's not going to fail, for example, addition, you cannot fail an addition, then map should be enough. All right? Okay, back to the talk. Please appear in there. All right, if I go here. Cool. Alrighty. So we can say the following. We can say that monads are parameterized types that implements two methods. Methods are unit, or the first one is called unit. In this case, is optional of, and bind. Bind is called flat map in Java, most of the cases. And also, they follow three rules that we are not talking about, but they have to follow them. Believe me, but we are not talking about. Right? Cool. That those things are monads. So again, this is quick. Transfer the normal type into a monad, optional off in the case of optional. This guy is bind, better known as flat map in Java. It receives a function and returns another monad of the same type, of course. Receives a function and returns another optional in this case. The function, we will call it the mapper function. And the mapper is a function that receives the value of the type parameter, in this case, the value that is inside the optional, and returns another monad of the same type. The type parameter can change, the type of monad, the wrapper type cannot change. It should be optional all the time, but you can have an optional that is a string, and you have a flat map that returns an optional integer, perfectly valid. It's another optional, another monad. A different monad, not the same, different. So, now why are they useful? And this is the fun part. If we get the flat map, this will be fine. Alrighty, so classic example, let's try to add two optionals. When I was writing the blog posts, I found a lot of people that says, dude, you cannot receive optionals as parameter. It's a bad pattern. You better receive the real thing and do the validation outside. And I'm like, cool, yes, that might work. But for the talk, we are receiving optionals, right, for the didactic purposes. So we have two optionals that need to be added. Trivial thing. All right, so what we need to do basically is first check that, all right, so if any of them is empty, then the whole addition should be empty. So we have the first one, and we check if it's present, and then we check if the second one is present, and we get the value out of them and we add them. Otherwise, we return empty. That's the way you add optionals, right? Traditional way. So what we need to check here is that we need to check that all optionals are present, and we need to deal with the case any of them is not present. How do we deal with the case anyone is not present? Then I need to create another monad. Optional empty creates another monad, another optional, sorry, monad, no, optional. Another optional that is empty, right? So we need to be careful of that, right? Because it might happen that sometimes we don't check whether the optional is present, and we just call get, and then we will have this beautiful exception on Friday night. So, go ahead.
Yeah.
Yes.
So, is monads the concept as in, is it beyond optionals, or does it just comprise optionals only?
Monads, you mean?
Use monads as a keyword instead of optionals?
No, monads is a concept that, yeah, is much more than optionals. Yes, it's a lot of other things, right? The thing is that optional is an implementation of a very famous monad. We will, yeah, I can talk to about you about that. Yes.
Did you say streams are monads as well?
Streams are monads. That's correct. Streams in Java, streams are monads, optionals are monads, and there is something called completable future in Java that is also a monad. Cool. Yes, you have that. So what we're doing here is that even though it's trivial, what we're doing is actually manually unwrapping the integers from the optional. We have to deal with the optional context ourselves. We need to know what to do if one of these things is empty, and we need to know how to get the value out of the optional context. All right? This is trivial, and optional is well known, but there are other monads that are not that trivial, and I hope we can cover that in this talk. So this is the monadic way of doing things. Bear with me with the indentation. There are utilities that we can use. I won't cover the utilities here, but in the blog post that I will share with you, there are the utilities in there. And this is another way, right? So this is weird because we actually have a second flat map nested inside the first one. So that's why the two things in here. All right? So what we're doing is getting the first value. Remember that this parameter is the parameter that is inside the optional as a parameter in there. And we're holding that in the scope. All right, you are still in the scope. And inside the function, as the functional body, I'm actually calling the flat map of the second method. And I'm getting the second one in here. Both of them in the scope. And at the end, I just add them. Right? But because the signature requires, the flat map signature requires that I return an optional, then I use the unit method. In this case, it's optional off. All right? Unit method and flat map. The two only methods that I use in these compositions are monad methods, unit methods and flat map. So it's not that different in this case with this. I mean, most of us left the same number of lines because this one is too trivial. We will see something a little bit more elaborated. But what I want you to get from here is that we are actually interacting with two monads, and we only use the monads methods, and we get things for free. What things we get for free? The implementation of flat map in optional won't call the function if value 1 is empty. So the second thing is not called. It will be called only if value 1 is not empty and first is actually something. Once we got first, then we call the second one. Again, if value 2 is not there or is empty, then the third sentence won't be called. It will return empty. So the context, the optional context is preserved between flat map calls. And that is what monads give us. They abstract us to deal with the context. Again, the optional context is trivial. But we don't need to think. We don't need to deal with them. We just say, OK, I don't know how to get the value out of these two optionals. I don't need them because I return in another optional. And I know optionals are monads, so I can use this way. All right? Again, trivial, not many benefits. Let's see if I can convince you other way in the next slide. Again, we only use the monad methods, bind and unit, and we don't need to deal with the optional context. There is no checking there if it's empty or not empty. What do I do? Should I return empty or what? No, it's handled by the monad itself.
Where do you get the words first and second? Are they variables or are they?
Those are variables. These are whatever you want to put in here. This is lambda. These are just lambda expressions. Pure Java 8 lambda expressions. So you can put any variable in that. So that could be called value 1 type parameter value. And then you can call it value 2 type parameter value. Because what is that they mean? It's whatever you want to put in there. Yes?
I guess it's the value that you get when you call val1.get method.
Exactly.
It exists. That's the value.
Zero consider empty value?
Sorry?
Is zero is considered
No, in this particular operation that I'm doing, 0 is a valid value.
So if I have number 1, 5, number 2, 0, and I change the formula to first divide by 2, and it should give me an error, right? There's no check, right?
0 is a value.
0 is a value.
Yeah,
So,
but 5 divided by 0.
so in that case, in here, if you want to divide by 0, what we can do is basically put a body in the monad and return empty. Look, I see if I can. I mean, yes, I don't have the samples and it will take longer. But yeah, what you can do here is that, this is one sort of syntax for lambda expressions, but you can put actually a body in the lambda expression. And then in the lambda expression, you might check, all right, so this is business logic, right? It's not monad manipulation. It's business logic. And you say, all right, second is 0, and I want to divide first into second, then I cannot. So if I do the business check and say, if second is 0, then return empty. And then the whole thing is valid again.
So you say if first or second are empty, the flat map doesn't call the rest of the...
It won't call.
Okay. But if you want the functions to still be called, is there a way around it, or do you have to stop using flat map? And
Yes, you cannot use it. You can use it. The functionality in the flat map monad is that it won't be called. Because checking whether, the normal use of things the normal use of the monad would be, all right, dude, if you don't have something here, then don't mind. What else are you going to do? You don't have anything there. All right, so the flat map gives you that manipulation.
What is the error checking mechanism for this one? Is there any error checking mechanism?
For example, what type of errors?
5 divided by 0?
Again, not in this particular case because I'm adding things, but if you want to put some error checking, you can build it inside the flat map. So instead of writing this, you can write your own error checking. All right? You can put a proper function body in there, and write your own error checking. It's because error checking is part of the domain or business logic. It's not part of the optional manipulation. Optional is handled by the monads itself.
Here's a question regarding the error checking. Can I throw exception inside the method body in the flat map?
Yes, that's a good question. I haven't done it. I guess you can. You can throw exceptions in Java. Java is very good throwing exceptions. So you can throw exceptions in Java and it will break the whole thing. Yes. Yeah, it has to be a runtime. It has to be. It cannot be checked. It has to be unchecked exceptions.
So yeah, that's something to look into.
Yeah. It's good. It's good. Yeah, good question. It has to be unchecked exceptions.
Can we have a function call from there on the private?
Yes, of course. Inside here, you can call any other function if you want to. And we will have an example for that. Cool? So again, the good thing with that is that you have the optional monad and you can interact using the monad methods. Because you are using the monad methods, there are a lot of other monads that you can build, custom monads, and we will build a couple of them here. Every single monad that you use can be composed the same way, can interact the same way with only flat map and unit. You don't need to know how to get the value out of the wrapper type. There are, in other languages, I think in Java, in the completable future, you cannot just get the value. There is no get. So the only way to interact with them is through monads. And again, it takes the contacts out of, we don't need to manipulate the wrapper context, which is optional in this case, when composing with monads.
So on that previous slide,
Yes?
it's essentially just adding the two numbers.
Yes.
But what it's giving back is not the result of that addition, it's another option.
It's another optional. It's the same thing as here. So this is because any of the optionals can be empty. So if you get this can be empty, this could be empty. So if any of them is empty, I cannot add. I just have to return empty. Because both of them are empty, what do I add? Or any of them are empty.
But the fact that you're doing first plus second, that means it's unboxing the integers somehow?
So we can call them unbox. Yeah, well, of course, this is unboxing this integer. Yes, definitely. This is unboxing the integer. But apart from the unboxing feature of Java, you have also, it is unboxing and unwrapping from the optional context. So it unboxes from the integer and unwraps from the optional. Yeah. Cool.
So I could use the result of that method as part of another plus.
Yes.
And it would work because Java knows when it sees an optional, it can do the unboxing.
Yes. So you can do here flat map something else if you want to. So exactly. So that is what you're saying. The unboxing happens from the integer to the actual, because integer is an object. You cannot add integer. It needs to be unboxed into the primitive type, and then you add it, and then you box it again. It's different than the actual wrapping and unwrapping from the monad.
So if I did system.out.println on the result of calling that method, I would be printing out optional.toString. I wouldn't be printing out the integer.
Exactly. You will print optional toString, which in this particular case will be optional of the result of the operation. Good? Yeah, I'm glad you're still here. All right, composition. This is crap. Basically, when I say composition, is that I am nesting the flat map. As you can see, the first flat map there is not chained. Actually, the second flat map is nested inside the first flat map. So that's the composition we're talking about. I'm not talking about object-oriented compositions in which you have an object that composes another object. I'm talking about function composition. Flat map is a function that receives another function, and I put another function inside. It's composing the thing. So the composition I talk about here is that we have three classes, A, B, and C, and we have a method that's called B, returns B, and receives A. And I have another method that returns C and receives B. So since this method receives B and this method returns B, I can put this method inside here and do method 2, method 1, A. So that's composition. It's functional composition. It's not, yeah, I don't know why did I put that there. Doesn't make sense. Anyway, go ahead.
Do you know if coding flat map a lot is it a heavy load on the CPU? Or,
I don't know. I haven't used it. I haven't had any problem with performance. From the way I implemented it, because we will implement some monads later, it doesn't look like it's a lot of weight, a lot of processing power. Should be the same thing. We'll see once we get into the monad. So another optional example. This is a quick one. So this, I think, will show you a little bit more of the benefits. So over there, we have something called counter. And then inside counter, we have color count. So counter is an object that has an optional property, color count, meaning that color count might or might not be there. All right? Yeah, nothing related with printing, but yes, correct. Yes. How do I zoom this? Great. All right, this thing. I have a method called color count that returns an integer. It could be there or it could not be there, right? And this is a type. Then I have two methods, right? Let's assume that those things are implemented, right? Fetch this month counters and fetch previous month count. Yeah, it happens. I do have to do that in printing. All right, so that thing, the fetch might fail. I can fetch them. I can try to fetch the previous one and might not be there, so it's optional. Same with this current month. So we will return an optional counter that contains inside an optional color count. So even though I can retrieve the counter can come with an empty color count. All right? Weird. It happens. So I want to calculate the total color count. The total color count from the previous month and this month. So what I do is I fetch this month counters, I fetch the previous month counters, so that both of them are optional. Then I check. And I start doing this thing. If this month is present, and then I get it, and then I get color count from the counter that I got in here, and then I have to check that it's present. And then if previous month is present, and then previous month get color count is present. If all of them is present, everything is present, then what I do is I get the color count from the first month, and then I get the color count from the previous month by chaining optionals, and at the end, I just add them. I guess we have done this, right? Some cases. Not with the counters. I don't expect anyone writing with printers, coding with for printers, but yeah, that happens. So let's see how can we do this in a monadic way. There you go. We have still the two methods that fetch, but then we have a rather smaller chunk of code in there. So what I do is that I fetch the first month, and I do a flat map, because what I want to get is the value inside the optional. And then the flat map receives a function. And then the function returns another optional. All right? Counter color will return another optional. So this is syntax sugar from Java 8, right? This is just again syntax. This is a lambda expression in there that returns another optional, right? And then because this is another optional, I can get the value there. And because I can get the value, I can hold it there for the next, because I need to interact with something else. I do the same thing inside, and I get optional, and then I add the two things. Yeah, I know sometimes it's not that easy, but yeah, this works, and I can show it.
So with this example, if you only have 1 month, they've only been using the system for a month, you're going to get empty, or will you get a total only including 1 month?
No, this particular case, because the business requirement is like that, you need to have at least 2 months to calculate the total. It doesn't make sense to have only 1 month. So if any of the 2 months is empty, or any of the 2 counters in the 2 months are empty, then you need to return empty. Otherwise, you need to add them. So in this case, I fetch the first month. If it's not empty, then I get the color out of the first month count. And if the color is not empty, then I store the value in this variable. And I do the same with the previous month. If the previous month is not empty, then I get the color of the previous month. And in case it's not empty, then I store the value in here. And then because I have these two things in the scope, then I can do optional of color 1 plus color 2.
It's clear now. What if I wanted to know which one is empty?
So that's another thing. So this particular approach don't give you that. This particular approach will give you, because of the signature, the only thing that it has is, all right, I want an optional with an integer. I don't mind what is there. I can just return empty, right? But I have an example for your question, and we'll solve it if we are able to finish this talk anytime today. So, yeah, but yes, you're right. Yes, it can be done. So there is another monad called the result monad, and it's a custom monad. It does not exist in Java. We will code it together, and then we can have, instead of an optional, a result. We'll see. Good question.
Thank you.
No problem, man.
Can you just show the previous slide for a second?
Yes. This. So here you need to check that every single thing is present, and after you check that every single thing is present, you need to get the value of the nested optional, and once you get the value of the nested optional, then you add them. Right? There is a lot of things that you need to know about optionals to be able to do this.
Where is that color coming from in the other slide?
So in this, this one, this is the counter. This is the object. This is the object that I'm fetching. I'm fetching this, and I'm returning an optional of this object. This object might or might not be there, and the parameter is optional. So this counter, of course, the counter, let's think about a counter of having a lot of other things. It has total counts or whatever, a lot of other properties. One of the properties, the one that I'm interested in, might be optional. All right?
Well, in the previous one, you had counter, color. Where is that color coming from?
Color count, not the sound.
We'll see here. Yeah, you're right. You're right. There is my mistake. Should be color count. Color count. It's that method. It's this method here. Sorry. Yeah. I'm sorry. Yeah. If this were not complicated enough, I'm actually putting typos in there. Yeah. I'm sorry.
It's not sleeping, you know?
Yeah. Good catch. Yeah. Yes. It's color count. Color count. Well done. Sorry. Yes. Yes. Please.
It's a little bit more complicated question on this.
My God. All right.
If I want to have, I'm not sure if you can do this, but if the color 1 is empty, then add color 2 with 0. If the color 2 is empty, then add color 1 with 0. So the
Yes.
value,
Yes. Yes.
like default value.
You can have default values there. Yeah, sure. That's a different sort of a different treatment, and we can find another way of doing it. Right? Yes, you're right. We can put default values in there.
There's a method, dot or else.
Or else, for example. Right.
Well, okay, good.
So yes, that's part of the optional itself, but it's a little bit outside of the monad concept that I want to bring. But you're right, it can be done like that. In this particular case, all right, we have particular requirements, right? The particular requirements are that I don't mind which one of them is empty, and I just want to add the whole thing, right? And that's it. And I don't want to have any errors or whatever. That's it. I want to add the thing, get empty or get a value if there are presents. That's the requirement. Cool. But yes, you're right. That is a very valid point. Whew. All right. Continue. Cool. So let me show you something here. Apart from that, we have extra benefits. What are the extra benefits? The second fetch won't be called if the first fetch is empty. So we save one fetch already. Another benefit. So not only that, if anything in the top is empty, the second fetch won't be called. Alrighty? So yes, again, it's one free thing that we get by using monads and composing things. And again, we have only talked about optional. We will talk about the result monad later. It's the same thing for all monads, even for lists. You can have the same concept for lists, for streams, not lists, streams. List is not a monad, unfortunately. Flatmat can be used chaining or nesting. Yes, we see that. In this case, this first one is chained because we don't need to interact with anything else. This second one, because we need to interact with another optional, then we need to nest the second one inside. You will have this, and you will have the blog post if you want to. If you are more interested in this, and of course, I'm super available to talk to anyone. Yeah, I just want to finish eventually. Write only calls the nested function is needed. Cool. Alrighty, so that's one of the built-in monads that we have in Java. Let's talk about the result class. I had prepared 2 monads more, result and logs. We are not going to talk about logs because I want to leave today, but we're going to talk about result class. And then the log class, you can check it in the blog post that I wrote, or in the I guess we can share this presentation as well. So the result class is a very, very basic class as well, and very similar to the optional monad. What is the result class? The result class basically gives you either a value or an error. The optional monad will give you a value or empty. The result monad will give you a value or an error. An error in this case would be a string, but you can have an error of any type. You can have an exception, you can have an object, you can have any type, right? So for example, the first line there, it will be called read int from file. I pass the file name and I get a result. That result can yield an integer if it is valid, or is an error. And then we can have another business method that is pretty logic. It's called adjust value, and the name is awesome. And then you receive an integer, and if the integer is greater than 5, then you return an error, which is a string, a result with an error, or you can return a result with an OK value. All right? And then we have another method called calculate average. The calculate average, basically, there is no way they can fail unless integers are empty, but integers are null, but we'll never put nulls in integers. And so there's no need to return a result. It can return a straight value, double, right? So we will use these 3 methods. Remember, read in from file, adjust value, and calculate average. And then we'll see how we go.
Excuse me.
Go ahead, please.
What was that divide by 2d?
Because I'm returning a double, and I'm passing integers. So Java requires me to define that it's double. This is Java. Cool. So what I have to do, I was given this task, and the task is I need to read 2 ints from 2 files. I need to adjust the first one. I need to calculate the average, and I need to return a result. To do that, we go to the IDE and we do it. If I can find the mouse, please. Yep. Alrighty, we have this. Let's roll back this. I didn't want to do the. In fact, all of this thing was out. Alrighty. So, result. The not monad result. All right. So. Yeah, we need to do this. We need to read 2 ints and then adjust the first one and then calculate the average. All right? So the result type, let's go and check the result type. This is a not monadic result type. It's a very easy one. We have 2 optional values as attributes. One is optional value and the other one is optional error. So the result could be either a value or an error. The value is the type parameter. The error is a string. Just a private constructor for easy constructs them, and then I can have an OK static method that will produce a result with an OK value, or I have an error that will produce a result with an error value. And then I have helpers method that says is an error, and then get the value out of the error and get the error, right? Not a monad yet. We need to transform this into a monad. If I want to actually use that thing, what I need to do is that I need to read the first int from the file. I need to check if the read is an error. And if the read is an error, I need to return that error, right? And then I need to adjust that value. The utils class is the class that actually has the methods there, the methods that I described before. And then I need to adjust that value. And the value can be an error as well. So I need to check if there is an error, then I return another error. And then I need to read the second int for the second file and check error again. And then after that, I need to calculate the average and return. Sorry?
Simply return the error directly without wrapping it again?
No. The reason is that this read int from file returns an error of type integer, a result of type integer, and the whole operation expects a return of type double. So because of the awesome Java type system, I need to create a new error and wrap the previous error. Alrighty?
Sorry, mate, your new error there, would that not be results of parameterized type string?
Sorry, result of what?
Would the parameterized type of the result there not be string?
No. Again, the result, let's check the result class quickly. The result class in here, the parameterized type is the value, the error is always a string. Yeah. It could be something different. You can build it however you want, but in this case, it's always a string. So in this particular case, I need to do a lot of checking. But then we are going to transform the error into a monad, and we are going to code the monad ourselves. How cool is that? Yeah, super cool, I guess. Then what we need to add is, forget about this method. This is just another implementation that I was doing. It's just typical to string equals hash code, not needed at all. We need to focus on this method. To transform this into a monad, we need to follow the rules. The rules are implement bind and unit, and follow the three sort of rules. The rules are, we can follow the rules. Believe me, I won't talk about them. But we need to implement the flatman method. We have the unit. The unit is OK. It takes any value and returns result. So we already have the unit. We need to implement the flat map. The flat map is there. So the flat map, again, is a method that returns a monad, in this case, the result monad, right? And receive a function. The function receives as parameter the value of the type parameter. In this case, is t. So we receive t here, or anything that extends t. And returns another monad of the same type, result. But look, it's u. This gives me the chance to get a result of integer and transform it in a result of double or result of string. But it's a result still. And the function is called mapper. So what I do is, if this particular result is an error, I don't do anything else. I just return a new error with the value that I have. All right? So when I call flat map, if I am an error and someone calls me with a flat map, then the only thing that I do is returning that error. I don't do anything else. I don't need to do anything else because it's already an error. So the error propagates. If it's not an error, then I call the function. The way I should call the function is apply. That's Java 8, right? I apply the function. And the parameter of that function, what parameter the function receives? The type parameter. The type parameter is value. All right? So I need to get the value out of the optional. Of course, this might fail in thousands of ways, but this is the easiest approach that I could take. All right? So I pass the parameter that I have in here. I pass it to the function, and I call it. And the return of the function, according to the signature, here, the return of the function is a result. So this result is the one that I'm returning here. Yeah, you can have a read of that. It works. But it's a flat map. It's a bind. It's the good old flat map we have already used in this presentation.
Result itself is not a monad.
It is. This is a monad. Result is a monad. So this result, I can chain it with another flat map, and so on and so forth.
So there's no monad interface that it has to implement?
No. I thought about that, and I wanted to put a monad interface so that we can have flat map for free. Not possible. Because Java type system is not strong enough. It lacks something called higher candidate types. But I won't even talk about that. Cool. Yes, I can sit with you. I can try to explain why I cannot have a monad interface and have a generic map function. But for now, Java is not strong enough to support that. We can again discuss about it later. Cool. Now we have flat map. We have unit. We need to. What we can do is write the example, and the example is too simple. We read the integer from the file, and I have a resort integer, and then we flat map with adjust value. We need to adjust the value of this integer. And the return will be an integer again. All right? Same Monads properties. This flat map, this method will never be called if this is already an error. So we save already that. And with this value, so when I'm saying this adjust value, and I wanted to show you this is no more than another lambda expression that I could do right? Same thing. It's just syntactic sugar. But at the end, this flat map received the value that I get from this integer, this integer inside, and I just can adjust it to return another result, because the adjust can also fail. All right? And then I can chain it. Oh, sorry, I can nest it with reading the int from the second file. And this value will be there only if this returns a positive result, not an error. And now that I have the two of them in the scope, I can calculate the average. Super similar to the optional, a different monads. And every single Java class that conforms to the rules have a flat map, and a unit can be composed the same way. The same way. This, of course, I could have done this just because for readability purposes, but I could have gone this way. Right? Read the first int, get the value out of the int, adjust the value, then get the value out of the result, read the second one and do it. Yeah, but then it will go too big. So it's good to split it and have, partial results, more readability and stuff. Yeah. Alrighty? Yes, please.
Can you open the result Java class?
Sure.
Because the part I'm a little bit confused
Is here, yep. Here it is.
Yeah. How does the flat map knows the error is the error, so it should stop executing it next?
Here. So this result, so we have a result that is called flat map. And the result, to the result, someone called the flat map to the result. Then what I do is that, okay, man, it turns out that I have an error. So I cannot call the mapper function. I cannot call it. So that's what I'm checking. If I have an error here, then I return another error, and then I get another error transferred. So this is
Flat map is responsible to propagate the mapper inside.
exactly. That is what it means dealing with the context. Inside the flat map, you do all of the context manipulation. You do the error checking, and you do the method calling and everything, and you don't need to think about it outside. So this is logic that should belong to the flat map, to the result. The result is the one that will do that. Outside the result, you don't need to check whether something is an error or not, because you already have a result as a response. So you basically can interact with the result things and get the value outside.
Where is the apply method implemented?
The apply method is by default implemented in the function class from Java. So apply is a Java. So if as you can see here, let me show you. This function is a Java 8 function that already contains an apply method. Here it is. Yeah, it's a functional interface. That's the way you call functional interfaces. Just to wrap up, I know this has been a long talk. I will finish now. Just quickly, let me finish, please. All right, sorry. So I will finish now. There is a log class that instead of I won't show the code, but instead of actually chaining the results or checking there is an error or not, it will keep a trace of all of the changes that a value can have had in the past. So basically, you can have a result with a trace, and you can have as many results with traces as you want, and then at the end, you can combine them using flat map, and at the end, we have a single log with all of the traces and all of the changes that has happened to the value that the logs wraps. And that is also a monad. And it composed the same way. It uses flat maps and unit. Same way of results, same way as optional. Again, you can see that in the blog post. Yeah, sorry, it went much longer than I thought. Yes, yeah, that could have been good to talk, but yeah, maybe in any other occasion. Yeah, finally. In Java, monads are just another tool. It's not mandatory, but in other languages, like Haskell, you need to use monads. I guess in Scala, you need to use monads as well. Pure functional programming languages need to use monads. This case is optional. So the classes we have explored are implementations of well-known monads. The optional is an implementation of the maybe monad. It's a well-documented monad. The result is an implementation of the either monad that's also well documented. And then the log, we didn't talk about it, is an implementation of the writer monad. There are more monads. We have the reader monads, we have the IO monads, we have other type of monads. There are monads that cannot be unwrapped. What does it mean? The optional monad has a parameter, and I can get the parameter out using the get method. But there are monads that you cannot do it. And I'll give you an example. In JavaScript, I don't know if you've used promises. A promise in JavaScript is a monad. The bind method is called then, right? If you have a promise, you cannot get the value out of the promise. You cannot get promise.get. No way. The only way you can get the value out of the promise is by using then and passing a function. The function is the same mapper function. The thing is that we don't have types in JavaScript, along other things that we don't have in JavaScript. But yes, but this is a promise itself. It doesn't need monads doesn't need types. So in the then method will receive a function, and that's the only way you can get the value out of the promise. And therefore, the only way you can interact with promises is using monads composition. Although nobody calls them like that, they just call it then and stuff, but it's basically a monad composition. Yep, JavaScript, a promise is a monad, which will be that thing. And then, yeah, thank you. I will pass the two links. I wrote 2 parts of this, that I put in a single talk. It was too long, but anyway. And all of the examples here are in my GitHub repository. And that's it, yeah. Hope you've liked it at least, and maybe it wakes the curiosity. Cool. No worries. Yes, please, questions. Say you have a question, go ahead, please.
According to you, since you've been using them a bit,
yeah.
What's the best thing with monads? I mean, for you, what's the most useful thing about monads? Why do you like using them?
I like that. For me, it's simple, and for me, it's more straightforward to not to check this amount of if this is empty, if this is thing. The code is for me cleaner, and it's safer, because if you don't use monad composition, you might forget to check whether the thing is in there, and then you will go straight ahead and do a get, and nothing will happen again until Friday afternoon when you're leaving. That freaking thing broke in production, and then you need to stay and fix it, right? So with this, it's safer, right? This you will leave the context manipulation to the thing. So for me, it's safer coding. Cool.
So less code to write.
Sorry?
It's also less code to write.
Yes, less code to write for sure.
Just given how late we're going tonight, I think we might just keep the questions at that, but I think Andrés would be happy to answer questions just after this.
Yes, definitely.
And also you
Sure.
can post the questions on Meetup. So
again, just a big round of applause for Andres.
Right, thank you.